in a lower dielectric constant material. Circuit on the right is the same type of circuit design, except using a higher dielectric constant material. And some of the basics of dielectric constant in regards to wave properties is a lower dielectric constant circuit, or a circuit using a lower dielectric constant material, is going to have a larger wavelength, longer wavelength, and also it's going to have a faster propagation speed or faster phase velocity. And then the high dielectric constant material on the right, that's going to have shorter wavelength and actually a slower propagation velocity or phase velocity. Now let's consider some transmission line concepts. And what I'm showing here is just a very basic setup between a system that you have generating energy, and within that system you have something that wants to use that energy to do some kind of work, and that's the load. And you have to connect them together somehow, so that's the transmission line. The transmission line could be anything. It could just be a simple conductor on a printed circuit board. It could be wires. It could be fiber optics. It could be a lot of different things. But for what we're talking about today, we're going to be thinking mostly about circuitry on printed circuit boards. Impedance is important, and really for a matched system, you want the output impedance of the generator to be the same impedance as the transmission line. And also, that's the same impedance as the load. It's kind of an industry standard to accept 50 ohms as a impedance for a single-ended impedance. Differential pair a lot of times is 100 ohms, and I'll talk about that a little later. But there is some amount of losses associated with this connection scheme, the transmission line itself. And that's just the nature of physics, that when you connect things together, there is going to be some amount of loss. And in this case, we're going to call that